Okay, when you receive the indoor Elliptica head, in the box beneath the transceiver head itself, you find the indoor mounting hardware. First thing we're going to do is identify a spot on the wall that would be an appropriate place for this device. And I'm using a stud finder here, both in the vertical dimension and the horizontal dimension, to see if there are any, well, in addition to studs, any electrical lines, any plumbing, or other things behind that wall. When we get to the point where we found the stud, we mark the position of that stud, and we're going to end up straddling that stud with the mounting plate. You can also go between two studs, but this is a fairly strong way to mount the device. Placing the mounting plate over the hole and using it as a template, we can mark where the 4 screw holes will go, and then drill 4 half-inch holes in that drywall. You can see several other holes that we've drilled here on this training wall. Next, we're going to use these toggle bolts, which are an interesting design. There is a metal fitting that's actually threaded on one side. We place that metal of the toggle bolt into the holes that we've just drilled. We hold on to the plastic collar with one hand. Place the metal piece into the wall, pull it taut. Take one hand and push down on this plastic collar while pulling with the other hand. Get it real snug there on the wall, and then pull away the excess plastic. When we've put 4 of those toggle bolts in place, we're ready to screw the mounting plate to the wall using the screws provided. We'll tighten these down using an L-handled 5mm hex wrench. You could also use the 5mm T-handle wrench that comes included in the kit. Now, to that mounting plate, we're going to attach the mounting arm. It's got hole patterns on it that allow it to be mounted to the same wall that the window's on, or to the wall perpendicular to where the window is, or even to the wall beneath or above a window. In this particular case, we're going to use it in the cantilever design, that is, where the wall is perpendicular to the window. We're going to attach it with 4 5mm hex screws. We can get these started here with the T-handled wrench, but to tighten them up, we're going to have to use the L handle. Get these hand tight. Using the fender washer as a spacer, we're going to attach the mounting tube to the mounting arm. And as you can see here, it can be put in a variety of locations on that mounting arm. To tighten it down, we can put a screwdriver through the hole that you see right in the middle of the tube and apply some torque there to tighten it down. Next, we're going to want to slide the transceiver onto the mount tube. and orient the hex heads to face away from the window, or in other words, toward the installer. This will make it easier to do the work. Once the clamp is placed on the mount tube, it won't come off, but if it's not tight, the entire transceiver head may swing downward. So you're going to want to have a hand on it at all times. Tighten the clamp using the lower set of 5mm hex screws. And then remove the access cover on the back by applying some pressure to either side of it. You'll see a lead attached to the transceiver itself that supplies power to the LED on the back of the cover. There's also a small cover on one far side of the transceiver head that covers up the sighting hole. Step one of the alignment process is to do a course alignment by looking through that sighting hole. We're going to loosen up the azimuth and the elevation screws, basically all of the 5mm screws on the back of the clamp there, to give us some latitude to maneuver the head around. And by looking through that sighting hole and placing the target in that sight, we'll get a good rough alignment. When we think we've got it, we'll tighten down on those screws. If you haven't put up the far side yet, you can use some other point of reference out there, such as a window or a target of some other kind. The permanent wiring will include the power cord, the management cable, whether it be copper or fiber, depending on the model, and the data cable. We're going to want to place these into this gray sheathing that's supplied with the kit. And by pressing the sheathing together, it opens up, becomes wide enough to actually insert all of these cable ends. We then thread the cabling through the sheathing by pressing down on it, making it bigger. By pulling on the sheathing, it has the opposite effect of tightening up and becoming smaller. Finally, we get all the connectors to come out the far side, maybe 6 inches or so extended from the sheathing. And then we want to thread these through the cable path hole on the far side of the transceiver next to where the send and receive aperture is. We're going to want to push enough of that cabling through there to make the connection but not have a lot of excess. We can clamp that sheathing to the mounting arm itself using plastic clips, which are included in the kit. We'll make the power connection. That power connector should clip into place. And then for this fast Ethernet unit, we'll attach the 2 RJ45 connectors, one for management and beneath that for data. In this case, we're using a crossover cable for the management side because we're going to plug this into a hub. Then we're going to apply a cable tie, which will give us strain relief for the power cable. We'll attach the other end of the AC power adapter to the wall and press the on switch. On the back side of that, there's a green LED that will tell us that the unit's on. The USB connector is placed right above the management cable, and the straight-through Cat5 for the field service laptop is attached and plugged into the laptop. Then we'll apply power. You'll see a number of light patterns of a test startup. You'll see lights for the management connection and the data connection and for the field service laptop connection. Under the Discovered Devices tab, we can see that the TTI software has discovered our indoor unit in this case. It comes with a default IP address and MAC address. But before we can connect to this unit, we're going to need to make sure that our IP address of our laptop is compatible with what we're going to load into the unit itself. I can do this a number of different ways. One way is to identify the network icon on the desktop, give it a right mouse click, select Properties, and then under Network and Dial-Up Connections, look for Local Area Connection, give that a right mouse click, again select Properties, and then select Internet Protocol TCP/IP, hit Properties one more time, and then select Use the following IP address, and we'll put one in just for test here. We'll put in a subnet mask and a default gateway and hit OK. OK again. Now we'll launch the Terabeam Transceiver Installer software. There's an icon for that on the desktop if I've installed it properly. I'll double-click that. And we'll find one device under the Discovered Devices tab. We identify it by its MAC address. It also shows its default IP address here. The first thing I'm going to want to do is change the IP address and some of the other network settings. So I'm going to click once on the device to highlight it, and then I'm going to give it a host name. I'll just call it Test Indoors. I'll give it an IP address. A gateway, and a subnet mask, which I'll keep the same. Then I'll click Modify Network Configuration. This is uploading those parameters from the laptop into the transceiver head. Now I can connect to the unit. I'm going to click the Connect button, and looking down in the lower left-hand corner of the TTI screen, you can see the connected indicator, and it's green. Now on our installation, I need to look at the camera view. On the toolbar at the top, you see a number of icons, and on the far left side, you see one that looks like a camera. So I'll click that once. The first time you do this, it takes several minutes for the camera to boot up while it installs various drivers and so forth. Finally, I get a shot of my camera and crosshairs. If I see the camera but no crosshairs, it probably means that I didn't connect. I didn't click the Connect button and connect to this particular transceiver. As you can see, I'm pretty closely aligned already on my training link here to the far side of the link. It's about 40 meters away. The first thing I'm going to want to do before doing my fine alignment is to change the link range from the default to the actual link range. For instance, if I put in 4,000 meters here and clicked the right transceiver button, you'll see as the crosshairs adjust for that new link range. In actual fact, this training link is about 40 meters. You should get that link range down to within about 20% of the real world. Once I see the crosshairs on the target, I can go ahead and start using my fine alignment screws to put the crosshairs right on the target. Now, in this training range, I can actually see the transceiver on the far side, but in most cases, that's not the case. I will see a spot where I'm going to put a transceiver, or I'll see a window, or I'll see a pattern of lights or trees or buildings or something where I'll need to aim the transceiver head. As I adjust the fine alignment screws on this indoor unit using the 3mm hex head, you'll be able to see the camera going up and down in elevation. And in azimuth. And finally, I should have the crosshairs centered on the target. In order to kick off the spiral scan, we need to go into the FSO performance screen in the TerraBeam transceiver installer software. So the second icon from the left is the FSO performance monitor screen. We'll click that. And if we look towards the right side of the display, we see two buttons, Start Fast Spiral Scan and Start Slow Spiral Scan. Neither one of these is active yet because it's still in a tracking state. So we're going to have to turn the tracking button into the off position. Why do we have a fast and a slow speed? The idea would be that on one side of the link, we would make that a fast spiral scan, and the other side we would make a slow spiral scan. And in this way, we would guarantee, hopefully, that the two sides will find each other. Potentially, if they were both traveling the same speed, they might never catch up to each other. And I always equate that to a dog chasing its tail. It never quite gets there. So we've turned the tracking button off. This enables both fast and slow. I'm going to hit the fast spiral scan here, and on the opposite side I would go over and hit the slow spiral scan. As I click the fast spiral scan button, notice the tracking state towards the bottom of the numerical window in the upper right hand corner. The tracking state says FSPRL, and that stands for fast spiral. On the other side it would say SSPRL for slow spiral. Now the spiral is confirmed on the left hand side of the display by the white dot. This is actually a visual impression of the way the mirror is scanning, and you're going to see it scan from a very narrow dot in the middle and an increasingly wider and wider circular pattern. As it's spinning around there, you can also see the tracking angle X and tracking angle Y numbers moving to, again, reflect the position of the mirror at any given time. The minute that this transceiver detects power from the other side, the tracking state changed from FSPRL, fast spiral, to FTRAK, or fast track. When you see fast track, you know that this side has detected the other side, and vice versa. You'll also confirm this by looking up to where it says receive power, minimum, average, and maximum. Notice this one has shot all the way up to 568 microwatts of energy. So we're getting power on the detector, and the mirror has basically stopped moving. It's moving a little bit now, but it's not in its spiral scan anymore. Finally, if we wait long enough, and it takes just a few seconds, the tracking state will automatically change from fast track or slow track into track mirror. And here you see it, TKMIR. That's the operational tracking state of the unit. So what we're going to attempt to do here is, by turning the fine alignment screws, we're going to want to zero out the mirror. That means we want this mirror perfectly centered in its field of view so that it has maximum range left and right and up and down. And so I'm going to take those fine alignment screws, turn them in both elevation and azimuth, and as I twist them, I will watch that white dot go up into the center of the crosshairs. Of course, while I'm doing that, I'm making sure that the tracking state says track mirror. So it's actively, the mirror is actively staying locked onto the far side. Okay, and this is going to give us maximum play of that mirror, the full 7 milliradians to the right and left. Finally, we're ready to remove the USB connection, the field service laptop connection, and place the access cover back on the indoor transceiver head. We'll plug in the lead that gives us power to the LED on the back. A solid blue light indicates everything's working normally. A flashing light would indicate that there are problems, and no light at all would indicate perhaps some power problems. Place that cover on, snap it into place. As one option, you can use wire mold or some similar sort of conduit to hide the excess wire that's going down the wall, or you could bury that wire inside the wall, fishing it through.